So, hello guys, once again, now that we have seen properties of determinants, these tells us we continue by finding now the determinants itself. Okay, finding the determinants. Okay, so we have three methods to determine the determinants. Okay, so we have three methods. So the first method is Sarus. Okay, Sarus or Sarus method. This is simply the shortest method. We have determinants by cofactor. Okay. And we have determinants. We have determinants by row reduction. So maybe just to explain, I'll handle these video by video. So for this video, we'll just deal with Sarah's method, then we'll deal with the determinants by cofactor, of which we know how to handle cofactors. The determinants by row reduction, these are new step that transforms us to the second or another step in linear algebra. So from this row reduction, we'll perform so many calculations. We'll perform solving system of linear equation. We'll perform inverses of matrices. We'll perform so many things. So this is the epitome of linear algebra. This is the bedrock of linear algebra. So stay tuned. Let's get into the video. So we'll look on Sarah's method. Sarah's method. So I'm told the matrix A equal 2, 6, 2, -3, -8, 0, and 4, 9, 2. Told find the determinant. So in this concept, we'll say we'll be using Sarah's method to get the determinant. For again, we can get the determinant of 4 by 4 matrix and any order linear on any order matrix. So for this case, so the method says step 1, write the columns. Write the columns. That's 2, -3, 4, and 6, -8, 9, 2, 0, and 2. Now, so I've written my columns. So I'll copy the first two columns to the right side. Okay. So I'll copy these two columns to this side. So I'll say 2, -3, 4, and 6, -8, 9. So I've copied the first two columns to the right side. And again, whatever you do to a row, whatever you do to a column can be done to the opposite side. So once we have that, so the Sarah's method says we take this diagonal, multiply it by this, added to the multiplication of this diagonal, and again we add that to the multiplication of this diagonal. That's the first step. And the second step is take these and the product of all the three elements added to the product of these and added to the product of these. We'll get our determinant simply by that. So we'll say our determinant, I'll say the determinant of A, okay? So I'll say the determinant of A, I'll say the determinant of A equal, I'll start from this side, from the main diagonal. So I'll say 2 multiplied, I'll say 2 multiplied by -8 multiplied by 2. That's 32. Keep in mind, so it's a -32 added to this line. So as you can see, there's a 0 here. So this is just a 0 added to, this is 2 multiplied by, this is 54. Okay, so this is 54. So it's a 27 multiplied by 2, 54, and it's a negative. So it's -54. So once we have added all those, we'll have to subtract that with, again, from this other side, the red one. So I'll say it's 4 multiplied by that, it's -32 multiplied by 2, it should be -64. And I'll add that to, this should be a 0. As you can see, it's 9 multiplied by 0 and multiplied by 2. So for this case, I'll add, this should be -36. Should be -36. Aha. So from there, so I'll get my determinant as, if I add these and add these, I should get a -86 and minus into, so these, if I add these and these, I should get an 100. So I'll get a -100. So I should get -86 plus 100. So I should get my answer as 14. So that's my determinant. So the determinant equal 14. So the determinant of A equal 14. So that's all for this video. We have solved for Sarah's method. So please like, share, and subscribe to my channel. Follow more to my videos. Check the link in the description. I've pinned the link from the previous video, how we did the inverse of that matrix, how we used the Sarah's method in the previous video. I've linked it here for like just to look for more examples on finding the determinant. So please check my YouTube video link to ordinary differential equations and quantum mechanics. So please like, share, and subscribe. Thank you. Have a good day.